In the previous video, we've been discussing about how the common carotid artery bifurcates, how it bifurcates to give two terminal branches, the external carotid artery, and the internal carotid artery. So the internal carotid artery and the external carotid artery. So today we are killing this, and remember it occurs at approximately level of C3, C4, even though we know we have some literature that they say this bifurcation can happen at C3, C4 or C4, C5, and we also have some anatomical variations whereby we have this bifurcation happens as lower as the level of C7. So don't worry about that. On average, an average level of bifurcation would be C3, C4, and even if you say C4, C5, you are right, and there's no problem about that. So today we are starting discussion on the carotid sheath, which is a membrane that encircles these common carotid vessels, and it starts by encircling both the the common carotid artery, and then the common carotid artery will bifurcate at the level that we know, and then the external carotid artery will leave from this carotid sheath. So the carotid sheath will contain the common carotid artery, and then after bifurcation, forming internal carotid and external carotid, the external carotid will leave from this carotid sinus, and then so the internal carotid will be maintained in this carotid sheath. So the three important structures that are encircled, that are wrapped around by the carotid sheath, would be, of course, the internal. So this is what we call the carotid sheath, this greenish stuff here, and then we know we have the internal carotid artery. So it depends on what level is cut. Oh my God, this is horizontal section of the neck. So when you cut through the neck horizontally and then you're looking from above, this is what you can see. So we have a lot of structures. We are not concerned with all other structures, but our point of discussion today here is the carotid sheath, so this membrane. So we have the internal carotid artery as part of the carotid sheath, and then we also have internal jugular vein. So we have two vessels in one nerve. This nerve is the vagus nerve, is cranial nerve number 10. Cranial nerve number 10, the vagus nerve. I know most of people confused and they think this would be the recurrent laryngeal, but that's always wrong, because the recurrent laryngeal nerves, they are somewhere here, just adjacent lateral side on either sides of the esophagus, and they are not encircled in the carotid sheath. So the carotid sheath only contains vagus nerve and two vessels, which would be the internal carotid and the internal jugular vein. So let's discuss about something very, very important here, which is carotid sinus and the carotid sinus. So we know at the level of bifurcation, that we said is the superior border of the carotid, the superior border of the thyroid cartilage will have bifurcation. So at this level, just before bifurcation, we have dilatation. We have dilatation of this common carotid artery. So the dilatation of common carotid artery, which is also a little bit on the side of the internal carotid. So this is the internal carotid artery. So the dilatation starts from somewhere here in the common carotid artery, and then it extends on the side of the internal carotid artery. So we have this dilatation, and this dilatation is what we call the carotid sinus. The carotid sinus is that dilatation, which is also correspond to the angle of mandible somewhere around here. So we have this dilatation. So what does it mean? Dilatation means increasing in diameter. So dilatation means we are increasing the caliber of the blood vessel. So whether it's the internal carotid or the common carotid, we have the increase in diameter. We have change in diameter, and we know if we change the diameter means we have changed the cross-sectional area of that vessel. And we all know from primary or whatever school, we have pressure is equals to force over area. So if we have increased the cross-sectional area, the pressure will never be the same. This is to say that the carotid sinus, this dilatation is associated with the changes in the pressure in the blood. So it is associated with the changes in blood pressure, It has got special receptors that we call them the baroreceptors, or pressure that will detect changes in the blood pressure. And once they detect this change, they they send the changes, they send the information to the brainstem. We had the cardiovascular center of the brainstem, and then this brainstem will respond by appropriate action. Whether if we have hypotension, if we have low blood pressure, and then it will respond by increasing heart rate and increasing the blood pressure, and that will be by sympathetic. I think you remember the sympathetic, parasympathetic stuff. But one thing to remember, of course, it responds to changes in pressure because it has got the baroreceptors. But the information are carried by the glossopharyngeal nerve. So the information from the carotid sinus are carried by the way of the glossopharyngeal nerve to the brainstem, and then the brainstem will take the information, appropriate action by autonomic nervous system, either parasympathetic or sympathetic. And if it's parasympathetic, we know that it will be by the way of the vagus nerve, cranial nerve number 10. But if it's sympathetic, we know we have the sympathetic chain. So if we have something very important here, so if we have exaggerated response of this carotid sinus, it can lead into profound decrease in the blood pressure. It can lead to profound hypertension and bradycardia that can result into the condition that known as syncope or even fainting or even syncope. And this happens sometimes when you have this carotid massage. The massage here will lead into exaggerated response, and this also happens sometimes in surgeries that are taking place around the neck. They can result in this exaggerated response, and that is carotid sinus. It responds to blood pressure. We have another friend of his, which is carotid body. So the carotid body, most of people confuse between carotid body and carotid sinus. They think it's something that we are just having terminology that can be used either ways. No, the carotid body is different. The carotid sinus was dilatation. The carotid body is a material thing. It is a material thing. So we have at the level of bifurcation here, in between the internal carotid and the external carotid, you have something like a body. You can see here, which is a little bit smaller, but it is seen better on the other side. On the medial side of bifurcation. So the other side. So if we flip this these vessels, you will see that we have this reddish brown substance here, which is now known as the carotid body. So the carotid body, unlike the carotid sinus that was responding to changes in pressure, this one responds to changes in the chemical environment of the blood. By chemical environment, I mean the level of carbon dioxide, oxygen, and pH. So if we have too much carbon dioxide in the blood, it will start into too much acidity of the blood, and so the pH will be a little bit lower. And then this carotid body, it detects this. It has the chemoreceptors that detect these changes in the blood, in chemical environment, and they send information to the brain, to the brainstem. And we know in the brainstem we have the respiratory center. So if you have too much carbon dioxide, means we have low pH, and so we have to raise the pH to have an optimal pH. So what happens is it sends information to the the respiratory center of the brainstem, and the respiratory center respond by increasing the respiratory rate so as to remove this excess carbon dioxide and to inhale a lot of oxygen so as to optimize this condition in the blood. So that's it about the it's a bit about it. So we can talk a lot about it, but now it assists in regulating the heart rate and the respiratory rate through the mechanism that I've said through. So the information is also carried by the glossopharyngeal nerve from the carotid body to the brainstem by the glossopharyngeal nerve. But the information will be the response will be under autonomic control, whether to increase or to decrease. That will be sympathetic or parasympathetic, and that will be the response. And lastly, now we have this is what forms the basis of the Cushing triad. I know we cannot talk about the Cushing triad at this point, but if you understand how the carotid body works, you will understand the Cushing triad, and I will have a separate discussion that we discussed about the Cushing triad. So that is it from today's discussion on these three structures, and see you next time as we are tracing the internal carotid artery, how it goes to the brain. So don't forget to subscribe and stay tuned. See you next time.